Hello, this is our video for Monday, April 6th. We're going to do some examples for 10.2 for two proportions. So when we our sample is separated into two groups, and then we're comparing the two groups to see which has a higher proportion. So first example of the day, does preschool help attend college? And what I mean by that is, are people who go to preschool more likely to end up going to college when they're older? Okay, so like in some sense, there's this idea that preschool gives you kind of like a boost academically, and if you have some kind of boost, maybe that somehow persists until you get to college, or even if it's not like a cause and effect relationship, maybe there's still a connection. Like families that send their kids to preschool are also the type of families that value college more, and so that would be more of an ambition of children in that family. I don't know. So basically, like, is there a connection between preschool and college? So let's see the data we have. So there's 62 children who went to preschool, and of those 62, 24 eventually go to college. And then in our second group, they're going to have 76 children who did not go to preschool. And in that group, 25 eventually go to college. Okay, so let's find a 95% confidence interval for the difference between the two proportions. So P1 minus P2, and by that I mean the proportion going to college from the preschool group minus the non-preschool group. So I'm calling the preschool kids group 1, the non-preschool kids group 2. We look at the proportion that went to college in each and do a subtraction. Okay, so I am going to run this entire thing in Minitab, and as long as we're doing this, why don't we run a couple hypothesis tests? So let's also do a hypothesis test with alternative hypothesis not equals to start. And then we'll redo it with an alternative hypothesis with with a specific inequality. So I guess the question I asked is, does preschool help? So the thing that we're hypothesizing, the null hypothesis is always that the groups are the same. So in other words, preschool makes no difference whatsoever. Up here I said, does preschool help? And if the preschool group is better off, I guess the proportion going to college should be higher in the preschool group. So that would make sense as an alternative hypothesis. Okay, so because I said, does preschool help, that does suggest we use the alternative hypothesis with a greater than, but not equals is the default, and it's usually fine. All right, so we're going to run these three tests in Minitab: 95% confidence interval, alternative hypothesis with a not equals, and alternative hypothesis with a greater than. Okay, so let's flip over to Minitab and do it. Okay, so stat, basic statistics, two proportions. We have the summary data. In the first group, it's 24 out of 62 that go to college. And in the second group, it's 25 out of 76. Look under our options, want a 95% confidence interval. This hypothesized difference is always 0. Our null hypothesis is always that there's no difference, that they're the same. And we'll first do it with an alternative hypothesis of not equals. And I've been using estimate proportions separately. Pooled gives slightly different answers, and I mentioned last day that pooled is actually what gives the answers in the back of our book. But I'm used to doing the separate one, so I'm sticking with separate. Okay, so we'll hit OK and see what we get. All right, so the proportion in group 1 that went to college is a little under 39%. In group 2, it's a little under 33%, so the preschool group is higher, but the sample isn't that big. They're not enough higher to make a statistical difference. So the difference, our 95% confidence interval goes from negative 0.1 to positive 0.2. So the negative number would mean group 2 is bigger because we're doing group 1 minus group 2. So it could be that the non-preschool group, group 2, is 10% more likely to go to college. Or on the other end, it could be that the preschool group is like 20, 21, 22% more likely to go to college, or anything in between. And of course, there's a 5% chance that it's even outside of that range. And in particular, 0 is in between, that the difference between them is nothing. Preschool doesn't make a difference at all, good or bad. And looking down at our p-values, we get p-values. Our p-value for the normal approximation, which is the one I'm usually going to read off here, is 0.478. Okay, yeah, I meant to look up this Fish's exact, but I haven't gotten around to that. I think that's probably the one that uses the binomial instead. But we're rejecting the null hypothesis regardless. I mean, we're not rejecting the null hypothesis. As far as we know, the null hypothesis is true, that the two groups are equal. Okay, we do not have strong evidence of a difference between the two groups. So 95% confidence interval, negative 0.103 up to positive 0.219. And then I wanted to redo it with this slightly different alternative hypothesis where we're guessing that group 1 is bigger than group 2. And here we get a p-value 0.24. It's still a very big p-value. It's not any smaller than our normal significance levels of 5% or 1%. So as far as we know, there's no difference. And notice that when we do greater than in our alternative hypothesis, the confidence interval that comes out is this sort of one-sided one where we're saying we're 95% confident that it's negative 0.0768 or higher, up to infinity, I guess. So we haven't been using those one-sided confidence intervals, and that's not something I expect you to know. When I say confidence interval, I mean the two-sided one that's symmetric about the sample proportion. Okay, so that's the first example. I plan to just have 3 videos with 3 examples today.